It's still cold. I still don't have power, but my laptop runs on battery, so we're going to talk about the law of cosines. Now, just like with the law of sines, the law of cosines works for any triangle. So any, right? It just works for any triangle. So it doesn't have to be a right triangle. In fact, you really would want to use this for specifically for non-right triangles, because if it's a right triangle, well, then you can use your trig ratios and your life's a lot easier. Okay, but the law of cosines is really powerful because just like the law of sines, if we know certain information, then we can find any angle and any side of any triangle. And that kind of blows my mind a little bit. So in order to use sine or cosine, we need right triangles, right? So let's go ahead, let's go ahead and make some right triangles because we can do that. I'm going to drop an altitude here, right? And we'll call this our height so that I can use cosine. Now, here's what I'm trying to do. At the end of the day, I want an equation that only uses my angles and my side lengths, okay? I don't want an equation that uses the height, okay? And as you'll see in a second, I don't want an equation that uses really anything else. Just A, B, and C, either lowercase or capital. That's what I'm aiming for. So if I'm thinking cosine, well, let's talk about, with law of cosines, we're looking at the cosine of one angle. So let's look at the cosine of angle A. That would be this side length over C. So this side length, let's call it X. So the cosine of A equals X over C, meaning that X equals C times the cosine of A. And that's all well and good, right? But now, like I said, I just want to be using A, B, and C. I don't want X because I don't know what X is. So let's get this other segment. This other segment, right, would be B minus X. And, well, what I can do is I'm going to use the Pythagorean theorem and try to get a few more equations, right? Because if I have 3 equations, then I can get it in 3 variables. So let's get 2 more equations here. One equation is the Pythagorean theorem with this triangle on the left-hand side, right? So x squared, yeah, and we'll go ahead and use blue. That's fine. I am going to need some room. It gets a little hairy. X squared plus h squared equals c squared, right? So then, well, now I've introduced h into the equation, so I'm going to go ahead and try to get h out of there, right? So let's get h by itself. And this is going to start to look familiar to some of you. H squared equals c squared minus x squared. Okay. Now I'm going to use the Pythagorean theorem with this right triangle. Okay, and this one's really where I need the room. Because here I have b minus x, so here we go, b minus x squared plus h squared equals a squared, right? And now I know you're saying, oh, well, I have x. Let's hold your horses just a second. But I do have h squared that I can replace with c squared minus x squared. Okay, so let's go ahead and do that. Okay, so then this is b minus x squared. And then this is plus h squared is c squared minus x squared. That equals a squared. Okay, so I replaced h with c squared minus x squared. Let's go ahead and multiply b minus x times b minus x. B minus, oops. B minus x times b minus x plus c squared minus x squared equals a squared. Okay, b minus x times b minus x, that's b squared minus negative x times b, and then we'll do b times negative x. So that's 2bx plus negative x times negative x is x squared plus c squared minus x squared equals a squared. Okay, this is a big deal because now, look, I have x squared and negative x squared. So that cancels, oops, that cancels out with that. And I'm left with b squared minus 2bx plus c squared equals a squared. Well, look, I have x over here, right? I've got x over there and x over here, so let's replace that if I can. B squared minus 2b, and x is c cosine A, plus c squared equals a squared. Oh my gosh. I have just A, B, C, and angle A, and I can find, right, I have an equation where I can, if I have 3 of those, I can find the 4th one. That's amazing. This works for any triangle. So let's clean it up a little bit, if we can. What's a good color to finalize this in? I don't know. We'll finalize it in white. White is fairly distinct. So here we go. A squared equals b squared plus c squared minus 2bc times the cosine of A. And now I just want you to recognize a few patterns here, because we could have done this for side B or angle B. We could have done it for angle C. So let me go ahead and write out what would happen. We won't prove those, though you certainly could on your own time. B squared equals a squared plus c squared minus 2ac times the cosine of B. And c squared equals a squared plus b squared minus 2ab times the cosine of C. Now, are there any patterns that you recognize there? Well, one, if you're solving for a squared, then the angle A is over here, that I'm taking the cosine of whatever angle corresponds to the side that we're squaring over here. Right? A squared and cosine of A, B squared and cosine of B, C squared and cosine of C. Also, all of the letters on this side are the same. So B squared plus C squared minus 2BC. A squared plus C squared minus 2AC. A squared plus B squared minus 2AB. So these match up as well. You don't have to memorize this, right? That's the beauty of being able to write this down, having it with you. But just so you notice those patterns, that can be really helpful, especially when you don't have it all laid out in front of you as A, B, and C. So that's the law of cosines. And again, it's nice because this can be used for any triangle. Stay warm, and I'll see you next time.